Hello everyone, in this tutorial I'm going to show you how to do one-way ANOVA and two-way ANOVA. So what you see right now is a data file which contained a supplier and the parachute they supply. So here is the supplier. There are four types of suppliers, and this is a tensile strength, the strength of the parachute, how strong the parachutes woven together by using synthetic fiber. So these are the strength, and this is a loom. What type of loom is used in making the parachute material. So we have a two type of loom, and we have four suppliers, and this is a strength of the parachute, the tensile strength. Okay, and if you notice that the type of loom and suppliers, they are nominal variables, and the strength as a scale, the interval variables. So if you look at the variable view, just to show you here, the loom, we have a two type of loom, and we label them. One is a Jetta loom and two is a Turk loom. And the supplier, we have a four suppliers, supplier 1, 2, 3 and 4. Okay, and the measurements are nominal. The reason they are nominal, because the numbers, for example, doesn't give you a degree of importance. It just one is just a placeholder for supplier 1, and 2 is a placeholder for supplier 2, etc. Okay, similarly in the type of loom, the one Jetta is just represent 1 for Jetta and 2 for Turk. That again doesn't represent 1 is better than 2 or 2 is better than 1. Okay, so that's why they are called nominal variable. In other words, the number doesn't represent ranking, it's just a placeholder. Okay, similarly in the case of strength, strength is a scale, and scale represents the degree of superiorities. For example, obviously you can see that the number represent higher the number, higher would be the strength, lower the number, lower the strength. That's why we treat them, this particular measurement strength, as an interval scale. So this is scale. So normally anytime when you see a scale variable, that means you can take their descriptive stats. For example, you can calculate the average, which is mean, standard deviation, etc. So we can compute statistics on scales. Okay, so it's very important when you set up your data in SPSS that you need to know the measurement, and it doesn't really matter whether you use SPSS or other tools. It's very important that you know what type of measurement your variable is, because if you have a wrong measurement, or if you're using a different methods to do analysis with the then it might not work, because your measurement may not be appropriate for that type of analysis you want to do. Okay, so I want to begin with doing a one-way ANOVA. So in my one-way ANOVA, I want to first do a one-way ANOVA using suppliers. So one of the question we have is whether a significant difference exists in the strength of the parachutes by each supplier. So we have four suppliers, and we want to find out the strength of the parachutes provided by the suppliers. Each suppliers are same or different. So the null hypothesis in this example would be that there is no difference in the mean values. So all four means are same. So in other words, there is no difference in the mean tensile strength among the four suppliers. And whereas your alternative hypothesis would be that at least one of the suppliers tensile strength will be different with respect to their tensile strength will be different. So that's what we're testing here. So how would you do one-way ANOVA using SPSS? So this is what you're going to do. You go on analyze, okay, and in the analyze, look at the compare mean and select one-way ANOVA. Okay, and one more thing I want to quickly say, that why did we not use independent t-test? Because independent t-test also compare mean. Independent t-test work when we have two groups, okay, but when we have multiple groups, like we have in this example, we have four suppliers, so we would be using a one-way ANOVA. Okay, so click on one-way ANOVA and you get this this option here. So the dependent would be your tensile strength, because we want to find out, does the tensile strength depends upon the supplier. So factor is supplier. Okay, that's what we want to do that. So let me quickly go over what else we have. So you don't need to click on the contrast, leave the contrast as it is. However, you do want to look into the post hoc, and one of the post hoc tests we are interested in doing is called Tukey test. Tukey test is great, especially if you're dealing with the skill variable, in this case the strength we have. So Tukey test works great, and so that's what we're going to leave as it is, Tukey test. Now the reason we are using this post hoc test, because in case if the one-way ANOVA is significant, in other words, if we're rejecting our null hypothesis and saying that at least one mean is different, then we are interested in knowing which mean is different. That's why we are doing a post hoc test. Normally people would do a ANOVA test, then do the post hoc test, but these days the softwares are so powerful that you can choose this option right now. If it's significant, you can look up the post hoc result, but if the results are not significant, in other words, if you see the p-value is more than 5% for the one-way ANOVA, then you don't have to look at the results of the post hoc. You can ignore them. And that's pretty much it. You can click on the option if you want to do something else, like if you want to look at descriptive stats of the supplier by this what type of strength is supplier provides. You can look at the strength by suppliers, so you can have like a mean, standard deviation, those kind of descriptive statistics we're talking about. And there's also one thing which is also very nice. It's called homogeneity of variance test. So one of the assumption around the ANOVA is that the homogeneity variance. So what does it mean by the variance of those groups are equal? So that's the assumption we make. So we can also check for homogeneity variance. So we don't have to come back and do it again. So we can quickly look at the homogeneity variance, whether. So in this case, we want to support that the variances are same, so we can find out whether so here when you do the homogeneity variance test, we are looking for equal variances. So therefore we are looking for a p-value which is more than 5% in the homogeneity of variance test. Okay, because we are checking the variances of these four groups we have here. There's a mean plot. Since this option is easily available, so there's no harm running a mean plot. Just quickly show you the mean plot of just kind of show you that what's the mean look like. It's not necessary you need to do mean plot, but sometimes I find, especially if you're writing a report, sometimes it looks nice. What's the average of each group look like? So kind of it give you some idea, you know, which mean is more, which mean is less. So kind of give you a little kind of visual to kind of talk about your result. So mean plot is okay. So you continue, and again you can see the level of confidence interval is 0.95, right? So we can leave that is because confidence interval is 95. In other words, it's a 5% significance level. If confidence interval is 95, so therefore significance level is 5%. So we can leave them default 0.95, 95% confidence interval as it is, and that's pretty much it. So you don't need to worry about other options. You can leave this option as they are because they are not necessary at this point. So we can leave them as they are. And now you simply say okay. And you say okay, and you see a very beautiful result shows up here, which is very nice. You can see that it's a very beautiful result. You can see that is we have the suppliers, and these are the average value of the suppliers. These are standard deviation. You can see the standard deviation, for example. These are the confidence interval for the mean of those for a supplier. So it's kind of nice descriptive statistic shows up. And remember, I also talk about the homogeneity variance test. So SPSS also run homogeneity variance test for different criteria. One of the criteria used in the textbook is called based on the median, and but the SPSS is also produced the homogeneity variance test based on mean, median, and the other factor as well. But what is interesting thing about here is regardless of what homogeneity variance test was used, whether it's median or mean, you said that all these values, anytime you hear the word sig value, that really means is a p-value. So the p-value is all are more than 5%, because they are all are more than 5%. So we will reject the not all variances are equal, the alternative hypothesis, and in support of the null hypothesis that the variances are equal. So that supports our homogeneity of variance assumption. Okay, the third assumption of ANOVA we have. So that's a good sign. The next one is, which is a very important result, is called ANOVA result. So this is your this is your ANOVA result, and what we're really seeing in this ANOVA result is your the more important thing is the p-value, right? So of course you see this, the sum of squares among group, this one 134.349, and the sum of squares within groups. So in this case this is your sum of squares within groups, and we talked about in my lecture that if you take this number 134.349 divided by 3, the degrees of freedom will give you mean squares among group and mean squares between within groups. And if you take the ratio of these two numbers, 44.783 divided by 7.857, you will get 5.7. So this F is your test statistics. Sometimes it's also known as the F ratio, but that is the test statistics. And of course, you can open up your textbook, and using your textbook, you can find out your the critical the critical value of, in this example. So you can easily find out the critical value, and how would you find out your critical value? So what we have here is a degrees of freedom 3 and 36, for example, and that will give you critical value from the F table. But when you look at this ANOVA, of course you can look up the critical value from the F table, but it also provide you this p-value, this 0.03, and you see that this p-value is less than 5%. So that means that we are rejecting null hypothesis that the means of each suppliers are same. As a matter of fact, it suggesting that means are not same, they're different. So we accept alternative hypothesis. So this is how you read your ANOVA outcome. And because this is significant, this indicates that there is a difference exists between the groups. So of course, next question is which group is different, right? So in this example, so we have 4 suppliers, so we can able to compare at least a 6 pairwise comparison, for example. So we can look at the supplier, for example, 1 and 2, for example, and you see that 1 and 2, the significance value, this is very important, this column, significance values, which kind of easy way to find out whether difference exists or not. So it's pretty fast. Also you can see that in this example the significance is 0.002, which is way less than 5%. So therefore it indicates that there's a difference between supplier 1 and supplier 2. It's because the mean difference is negative, so it tells us that supplier 2 tensile strength is way more than supplier 1, right? And you can also see it also in between supplier 1 and supplier 3. So again, this p-value is more than 5%. So again, supplier 3 is better than supplier 1. So it seems that supplier 1 has a lesser value compared to supplier 2 and 3. But there's no difference between supplier 1 and 4 because p-value is 0.458. Okay. So you can see that this is way more than 5%. So therefore, statistically, there's a difference between supplier 1 and 3. So this is how you do multiple comparison. Anywhere you see this the value, which is p less than 5%, which means that the significant it's less than 5%. That means the difference is significant. And obviously, the smaller p-value, the higher the significance we have. So obviously, we can definitely see that seems like supplier 2 between supplier 2 and 1 seems to has the lowest p-value. So seems to that if you compare the supplier 2 and you can see the mean difference, supplier 2 mean difference in all areas are positive, and definitely is a significantly higher than supplier 1, and marginally significant for supplier 4 because p-value is not less than 5%, but it's in the 10% range. So it's not significant. However, it kind of indicates that supplier 2 seems to doing better than most of the suppliers. So basically, it kind of give us a good indicator. If you have to choose one supplier, and you would definitely going to choose supplier 2 over other suppliers, because you can see the supplier 1 is definitely doing way better than supplier 1. So supplier 2 would be the choice in terms of suggesting which supplier to choose. And you can also see that if you do this, the 2 key as HSD, you can see that supplier 2, 3, and 4, they are in the 2 groups, and supplier 1 and 2 in another group. So of course you can see that is supplier 1 has the lowest average value. And if you look at the this mean plot, so this is the mean plot I was referring to. So it's kind of also gives a very interesting perspective. It tells us that the supplier 1 mean tensile strength is the lowest, and supplier 2 has the highest compared to other groups. So as I said, sometimes mean plots are very powerful, and because they kind of give you a little bit of perspective, especially if you try to make sense of your data. So this is how you do your one-way ANOVA, and things are very easy here. For example, as you can see that if you are, for example, if you're doing your assignment, for example, so it's very easy to do this ANOVA in SPSS, because this is practically is your whole result of your assignment. All you need to do is just to state your null and alternative hypothesis, and practically copy and paste. You can copy and paste into your Word document, and your assignment is done. I mean, for me, it's less than 1 minute. But if you set up your SPSS file nicely here, then once you set it up in SPSS, then it will be less than 5 minutes for you. So this is basically how you do it one-way ANOVA. So what I want to show you the next is how to do a two-way ANOVA. Okay, so now what we have is a two variable. We have the supplier. So we just saw supplier itself are significant. In other words, difference exists among suppliers, and then we have a loom. So what we want to find out is, so there are two things happening. Actually, there are three things is happening actually. The one thing is happening is, for example, let's call loom as a factor A. So our null hypothesis is that it doesn't matter what loom you use, the mean strength will be same. So our null hypothesis is the mean for Jetta is the same as the mean for the Turk. Okay, so Turk and Jetta, that's what it implies. So that's a null hypothesis. Alternative hypothesis would be that that these two means are not same, the means are different. All right, so that's the first factor. So normally we call them a main effect. So if you treat loom as a factor A, for example, so we are testing the main effect of loom on the outcome variable, which is a strength. Okay, so that's the first hypothesis we are dealing with. The second hypothesis we have is due to, let's call supplier B as a factor B. Okay, is there a difference due to factor supplier B? So of course our null hypothesis is in this case that all suppliers mean tensile strength are same. Alternative hypothesis is that not all means are same. Okay, so this is the second hypothesis due to the main effect of supplier. And the third hypothesis is also very interesting, which is basic interaction between loom and the supplier. So we're saying that perhaps there is an interaction. For example, maybe if suppliers use a certain types of looms, maybe there is a strength might goes up, for example. So, or maybe it comes down, for example, right? So then we have this interaction. So our null hypothesis would be that, hey, there is no interaction between the type of loom and the supplier. So there is no interaction between these two factors. So if we call loom A factor and supplier B factor, so we're saying there is no interaction between supplier A and B. So in other words, interaction is equal to 0. Whereas our alternative hypothesis is that there is an interaction between loom and the supplier, and the interaction is not equal to 0. So in other words, there's interaction. So typically when we see interaction is this, for example, if you change the let's say if you change the supplier, if you're going from supplier 1 to supplier 2, right? So by changing your type of loom, does the strength changes, for example, from going from one supplier to another supplier, right? For example, let's say if suppliers is using a Turk loom, so does the strength varies which supplier is using the Turk loom, for example. So that's what we try to find out in the interaction effect. So when we're doing a two-way ANOVA, so we're dealing with the three hypotheses. So because of the factor A, in this example will be loom, because of the factor B, that is because of supplier, and the interaction, which is between loom and the supplier, okay, A and B. Okay, so let me show you how you can do this two-way ANOVA. Again, this is a pretty cool technique. So before I do the one-way two-way ANOVA, I just want to get rid of this output, because I don't want you to see so many results. Sometimes when you see too many output, and sometimes it looks kind of confusing. So of course you can save this result and I'm just going to go and delete this result because I can find the results again and again. And I already showed you how to do it, so you can also able to do it. But if you're doing it for your assignment, I would suggest save that result into a Word document and copy and paste it, and then you can have your work ready. And this is also important for your project also. Okay. One more point before I show you two ANOVA, I also want to make one important point here. Is you notice that my factor A, my loom, it is in one column. Very important consideration to notice that. And also my factor B, my supplier is also in one column, right? So this is so what we call them a treatment. So treatment of zeta loom and suppliers, the strength is 20.6. So typically in experimental design we call them a treatment. The zeta loom label and the supplier one label combined, they are treatment. So this is the strength of the treatment of experiment. Okay, so this is how we call treatment. And one more time, when you're for example, if you plan to use SPSS, and if you're copying and pasting your data file from Excel to SPSS, which you saw, the copying and pasting is seamless, it's pretty straightforward, and it's also very easy. Okay, so you know how to do that one. Okay, just keep that in mind, that make sure that your factor, for example, factor A, first factor, it's always in a column format. Okay, so and just one column for factor A and just one column for factor B. So this is very important. So I'm kind of telling it over and over again. The reason I'm telling it over again, because sometimes we forgot when we students bring their data file from Excel, and when they copy and paste, they tend to copy and paste as it is. They don't make an effort to modify it because they thought, if I just simply copy and paste. But if you simply copy it from Excel, then you will notice that Excel has so many columns, because what Excel is probably doing it, they are showing each number by supplier, right? So you'll end up having like 4 different columns, for example, for suppliers, and then you have strength. So just keep it in mind when you bring your data from Excel to SPSS, make sure that the data are in column, not multiple column for each supplier or each loom. Okay, all right. So now you got the idea what I'm getting here. So now you have a data file which is very nicely laid out. Now you're happy with the data file. Now I'm going to show you how to do your two-way ANOVA. All right. So this is how you do it. Analyze and go General Linear Model (GLM) and select univariate. Okay, I love this recording because you can watch over again. So if you miss, you can watch again and watch it again. So I think this is pretty cool. I think this feature was not available for students in the classroom, because if I was doing this thing in the classroom, I will show one time, and a lot of times students, they don't say show it again. They generally are quiet, and then and they miss any steps, then they kind of lost. But now you have advantage over sitting in the classroom, that you can watch my steps over and over again and until you perfected it. So that's kind of a cool part of recording this tutorial, which was not the option earlier. So you have one advantage. Okay, so univariate, here it is. I'm just going to reset my output here. So what we have, a dependent variable is your tensile strength, and these two factors. So remember, I'm calling a loom as a factor A and supplier as a factor B. You don't have to write down literally factor A and factor B. It's understood, but just to keep that in mind, when I say factor A here, factor A, I represent loom, and parachute supply, I represent factor B. Okay, this is how your textbooks talks about it. And don't worry about other factors right now. You don't need to worry about those factors, and it's not necessary for your course. So for now, just use your factors here in the fixed factor, because these are your fixed factors. So once you laid out, the rest thing is important. This was important step. Rest thing is, I would say, relatively easy. Don't worry about the model. Leave the model as it is. Don't change anything. Leave the contrast as it is. All right. I would definitely go on the plot, because from this I can produce a beautiful plot, right? So you don't have to use your graph paper and try to plot. And as a business student or an economics student, we know that a good plots you can only produce if you use some software. If you try to draw by hand, it doesn't give the professional quality. And anytime when you do presentation, you definitely want to have a good professional quality output. You don't want to sort of quickly draw by pencil hand, because it doesn't give the same skill, and the representation doesn't look very nice. It doesn't look very very clear. So I definitely will suggest use this this output from the plot, which give you a beautiful plot. So I'm just going to click on the plot here. So here it is. So you got these two factors. We have this loom factor A and supplier factor B, and it's asking you what do you want on a horizontal axis. So I'm going to choose a horizontal axis supplier, so the factor B, and I'm going to choose the loom on a separate line. I also have one reason why I did that. If you're paying attention, you notice the loom has only two labels, the Jetta and the Turk. The supplier has a four labels, so suppliers 1, 2, 3, and 4. And my personal preference is anytime when I select what is my A on A, B would be is I will use that variable which has more labels, because the idea is this, because when you're plotting something you want to have more label on your x-axis so that you can see the pattern. Because if you have only 2 points in your x-axis, then you don't really see much of the pattern. It's not very clear, because the more data you have on x-axis, then you can able to gauge the pattern. So that's my personal preference. Here it is. All right, that's why I choose a supply on a horizontal axis. I will definitely encourage you to think using that factor which has a more labels. All right, just add here, and that's what to do. Right, just asking what chart do you want. Do you want line chart, bar chart? Again, leave the line chart, because line chart is very nice. And again, don't worry about other options as well. You can leave them as it is, so don't touch anything, leave them as it is, and say continue. And again, the post hoc, remember, so here this is something I want you to think about it. So we have a loom. Loom has two factors. Do you want post hoc for the loom? And if your answer is no, very good, because you don't want to do a post hoc test for the loom, because loom has only two labels. If the difference is significant, in other words, the p-value is less than 5%, then we know that their difference exists, because they're just two groups. So we don't have to do a post hoc, right? However, in the case of we want to do a post hoc for the supplier, because we know that there are 4 suppliers, so therefore there are multiple pairs we can look into it, right? So that's why I only choose supplier, because supplier has more than 4 groups. All right. Next thing is to check on the Tukey test. And leave them all it is as it is, don't worry about anything else, and say continue, and that's pretty much it. It will be a very nice result. Here it is, look at that, beautiful, very nice. All right, so what we have here is a very nice two-way ANOVA results, and I want to quickly go over this two-way ANOVA result. And again, if you want to review what I'm doing right now, I definitely recommend you to do is to look at the lecture notes and follow my lecture notes. I also have my my recorded lecture which I explain all these things over there. So have a look at it and follow these things, so it will be easy to follow. Purpose of this right now is to not to really go each number, but to show you how to do it. Okay, but however, I will quickly go over how to read this two-way ANOVA summary table. So this is two-way ANOVA summary table. So we have this, so what I want to do is I want you to ignore the first 2 rows, the corrected model and intercept, because you don't need to worry about those two rows. What rows you want to study is the loom. So loom is remember loom is factor A. So this is telling you the 6.972. So this is a sum of squares. Okay, degrees of freedom 1, because there are 2 types of 2 labels. So 2 minus 1 is 1, and the mean squares is in this case is 6.972, right? And this is more important, and of course the f stats is 0.810. So how do you get this stats? So which is very easy. If you take 6.972 divide by 8.6612, and I'm just doing right now just to verify. So it's 6.972 divide by 8.612, and yes, you get 8.809,560. So basically it's round up to 0.81. All right, that's what you got. All right, that's why you got this number. And because you can see that the f ratio or the f statistics is very less. So if you look at the p-value for this this f ratio or f statistics, the p-value is 0.375, right? And of course you can't really find this p-value using the table, so therefore you will see this p-value in the output. So this is SIG, as I said earlier, the SIG 6 really represent the p-value. So p-value is 0.375. So what does it mean? It really tells us that there is no significant difference between the looms. So loom mean effect is not significant. Okay. And if you look at the supplier, there are 4 suppliers. So you can see that C minus 1, so this is 4, and the mean squares due to the suppliers 44.783, right? And the F ratio is 5.2. And again, how do you get this number? If you take 44.783 divide by 8.612, this is the error. Sometimes within. And that ratio will give us 5.2, and of course you can always look at the F critical value, which will be 3 and 32 degrees of freedom, the numerator 3 and denominator 32, but in this example you of course you can look it up your critical value, but we already have this p-value 0.05. So because p-values are provided to us, so we can use this p-value, and p-value in this example is way less than 5%, right? So therefore it tells us that here there's a difference exists among suppliers, and we already saw this thing when I ran the one-way ANOVA using this data set, so it was significant. So it's kind of tells us this is very interesting, the loom and supplier. So this is showing us interaction effect between this factor and factor B, and if you look at the F statistics is 0.011, which is way less, for example, right? And if you see the p-value for this interaction, which is 0.998, and you can see that this is way less, which is way more than 5%, right? So it tells us that there is an interaction between this loom and the suppliers. Okay, and of course we already have seen this two-key test, because when we did earlier one-way ANOVA, we already know that this is significant. If you look at a supplier 2 and supplier 1, you can see that this was significant, 0.004, the p-value. So we already been through this multiple comparison for parachute suppliers in the one-way ANOVA. So I'm not going to go over this table right now because I already talked about it. And so what I'm going to show you is this one. This is interesting. This is your interaction plot. So how do you really gauge interaction is by looking at the line. If the lines are parallel, as you can see, these lines are parallel, so there's an interaction. If the line was intersecting, for example, significantly, then we could say there's an interaction. And again, if you look at this plot, this is known as an interaction plot. And if you compare this interaction plot to the p-value, here is the p-value, which is 0.998. You can say the p-value is not significant, and interaction plot is also doesn't indicate any interaction. So it's basically saying that there's an interaction, right? I will bring one more point, which is very important. Sometimes the scales, when this results are produced, the scales start from 19, because scales start so quickly. There's only 6 differences exist. So the plot looks a little bit more dramatic. But if you double click on the graph here, and then you can change the scale. For example, if you change the scale, and then if you change the scale, and then you can able to see that the plot is way different. So there is a few properties. For example, I'm just quickly show you some of the properties. You can double click these properties, and you can see that what type of scale you see. So if you click on the scale, once you double click the scales, you can see the scales minimum is 18.42. So if I change my minimum to 0, for example, so you can see the chart looks very different now. You see the chart looks very different. Anyway, so if you double click the plot, you see all this property shows up. You can change the scale, you can change the text. So it's pretty user friendly, numeric format. Also, you can change a bunch of stuff, not decimal values. You can change all those stuff. So it's all possible. And if you're happy with this thing, and here you go, beautiful plot is produced for us using this SPSS. So this is how you do your one-way ANOVA, two-way ANOVA. I hope it's useful, and I hope that you can watch it again. I hope you can practice this thing. And once you watch this thing and you practice a few times, and if you still have questions, do not hesitate to talk to me. Come by to my office hours. I'm happy to talk about it. I love ANOVA. This is one of my favorite techniques, and I hope you like it too.